car today is a computer on wheels with a horn and typically a strong engine. Welcome to this tutorial on automotive electronics. My name is Christoph Ebert and I'm a Managing Director at Vector Consulting Services. Looking to this metaphor with the computer on wheels, we realize that it is not far away from reality. A car today has literally 50 to over 100 independent distributed computing systems which help driving. Now that means that we also have a lot of challenges with complexity that have evolved over the time. But let's look to these different challenges and also to the evolution in the next few years in order to see how automotive software will advance. The challenges are basically related to quality because we want to have ultra high reliable safety systems. We want to have cybersecurity because it's an ultimate precondition for safety. And of course we want to have good usability, good performance. Second, we see more and more service-oriented systems inside a car. We want to have adaptability, we want to have flexibility, so the software systems have to enhance. Thirdly, we have artificial intelligence increasingly inside the cars and of course in the domains connected to the car. Think about autonomous driving, where we need to continuously merge the different sensor information from cameras, radar and so forth, and then find out what's the best possible route, detect hazards and behave according to what drivers would expect. Finally, we have connectivity, which is not only necessary for infotainment, but also for a lot of the before mentioned services, where we have Car2X, which means vehicle to vehicle, but also vehicle to infrastructure connection. For instance, that the car knows about sudden hazards like another car crossing behind a curve or a sudden reduction of speed because of roadworks. These different challenges have to be mastered, but we also realize that with these challenges, the complexity over time has grown tremendously. If we go back to the 70s, we see electronic fuel injection, we see anti-lock system. That was it. It was individual electronic parts with very good safety, but also well controlled. If you look today evolution, we see new powertrain system with electric or hybrid drives. We see a lot of move in the direction of autonomous driving. We see also a lot of additional diagnostic and maintenance systems which are connected to the car. And now moving forward into the next decade, what we realize is mobility services, even higher connectivity, a lot of very flexible adaptive systems up to new services such as where we would not only drive autonomously but also at a given point move from the car into public transportation, into e-bike, etc. That is a seamless connectivity, not only in terms of commuting but also in terms of mobility. How are these different challenges managed? Well, the only way forward is that electronics will move at a very good speed but in a predictable behavior. And that is, we have to give up the classic electronic architectures in cars where we had functions mapped to control units into a modern three-tier architecture as we see it also in the Internet of Things. So let us briefly have a look to this convergence of IT and automotive electronic systems. The IoT or Internet of Things reference architecture with the three tiers has on the one lower tier the things and the devices which are connected to a computing system or distributed computing system with very high performance and the necessary quality of service. Finally, we have of course also connectivity into the cloud, where we get, for instance, additional services, where we get software upgrades and where we get functionality which would not be possible in a distributed system alone. The same evolution we see in automotive electronics. We have on the one side a lot of sensor actors such as brakes, the tire pressure, the different lighting systems, etc., which are connected to their individual controllers. But these controllers immediately connect into an ultra high performance and safety environment like we know today from airborne systems like planes, where we have a redundant system which is really capable of making all the necessary computing power with redundancy, with the necessary safety and cybersecurity as we expect from a car which drives autonomously. This again would then be connected via the infotainment telematic systems to the outside world, into the cloud, with a lot of different cloud services that would enhance the systems in the car and which would give additional functionality, but also a lot of driver assistance and environmental information. Having said that, we can clearly articulate that cars today have the highest IT challenges which we can imagine, and therefore invite to dig deeper. It's the place to be for electric and electronics and software engineers. If you want to dig deeper, feel free to go to this special issue of IEEE software, which we have compiled, my colleague John Favaro and myself, in order to show what are the current trends in automotive software. IEEE Software, the magazine for the leading practitioner, presents this, and we will have a lot of related articles that would give you further insight. Also, Computing Now, we have co-edited with a set of enriched articles. Have a look there and feel free to connect back with us. My name is Christoph Ebert and I'm available at www.vector.com consulting. Thank you very much.